Hey everyone. So thanks for coming, for staying here. Thanks Thorsten for hyping up my talk. Now comes my part of lowering your expectations. So also we are talking about transactional updates from OCI images. This is more or less a hack week project, and it's a hack and it barely works, so don't expect a working solution. So first, I'm Dan. I work for SUSE, not as impressively long as Thorsten, but I've been part with this company since before COVID, so it feels like an eternity. I've worked in various parts, but now let's get to the actually interesting part, and that's a bit of an intro. So this is about atomic updates, and first as a starter, what's an atomic update? And the really important part is that's an update that's applied fully or not at all. And you might now ask yourself, well, why is that really interesting? And for those of you who ask themselves the question are probably not sysadmins who did the big mistake of running Zypper up on a production server on Friday 17:30 before they want to leave on vacation. And then the upgrade breaks. And your system is in this funny in-between state of it's partially an applied update or not. And you don't want to be that, especially on Friday at now 6 p.m. and you know you want to leave tomorrow. And you now have to fix it because your company's database depends on it. So this whole thing is often coupled with read-only root partitions, and there's a whole ton of implementations. But today we want to talk about a different one, and that's bootable containers. And first and most important thing about this is not about running container images inside VMs and using or abusing something like Firecracker for that, but it's really to deploy an OS from an OCI image. So it's a different kind of abuse. It's abusing the OCI image format as a disk image format. And now you might ask yourself, why on earth would you do that if we have Qcode too? And that worked for the past 20 years. And one of the things is, well, probably most of us know how to build a container image and can whip out a Docker file in a minute or two. Now please build me a Qcode 2 image. So I can do that, but I have to look up the Kiwi manual and shout at the Kiwi command line for 2 days. I've tried it for the past 2 days, and I now have something that kind of boots, and there's still weird things, and the Docker file was finished 3 weeks ago. And the other big advantage of container images, we have a distribution infrastructure with somewhat of established upgrade paths. So the OCI registries, they are all there. We can put images there. We can download them from there. So this is a great infrastructure. And now if we want to boot from OCI images, it's in principle relatively simple. We have our image on the registry. We pull down our image. Then we have something, so the purple part, which magically or less magically applies our container images to the root partition, and then we boot from it. Sounds simple, and maybe it is, maybe not, probably not, because everything in practice is very hard. Then we have another piece in the puzzle, and that's transactional update, or more or less the utility behind it, TUI kit, so transactional update kit. I think you are probably mostly familiar with that, or vaguely familiar. So that's the openSUSE implementation of atomic updates or transactional updates. You have your root partition. On the root partition itself is a Btrfs subvolume. And if you want to start an upgrade, you create a new snapshot from your current root subvolume. You do all your update shenanigans into the new snapshot. Once you're done with the upgrade and everything succeeded, you switch the default subvolume, so that's what becomes the root partition on your next reboot, to the new snapshot, and you're set. Very nice, very simple, has the great advantage that it's still, you still get the atomicity of updates, but you don't have this nasty, I can't really overlay anything that you have with RPM-OS tree. And if anything should fail in the update, you just trash it and you're done. Okay, we're getting closer. Next part is the Btrfs storage driver from Podman. So Podman, that's one of the possible container engines that we have in openSUSE and on Linux in general. And Podman has various so-called storage drivers that are used to store container images. The Btrfs one is sadly a little bit neglected, and nowadays upstream mostly works on the overlay 2 driver, but the Btrfs driver is still there, and what it does is it stores images as subvolumes. So actually what it does in more detail is, so if you have an image, it's put into some directory under the graph root, which is just somewhere in var usually. It creates a subvolume for each container image, and layers are created as snapshots of the layer before that, which I'm not entirely sure why they chose that. Maybe it's provided some speed-ups in container builds, I'm not sure. But the important part is, each image is a subvolume. That means, in principle, how about we just switch the image itself as the default subvolume? And then we could, in principle, boot from it. And that's actually it. So the project, which I called Container Snap and implemented to at least the basics of that during the last Hack Week, I think in November, December, somewhere last year. It's called Container Snap, and it does literally that thing. So you have your container registry, there you put your operating system image, then Container Snap puts it in the Btrfs storage that's in varlib container snap. And then I abused TUI-Kit to massage the whole thing so that you can actually boot from it, because if you just do a Btrfs switch default subvolume, then it won't boot. You need also do additional things. And that's really it. So it's more than 10 lines of code. So since it's written in Go and you want maybe somewhat of a usable UX, it's a few more. But I've prepared a demo. It's unfortunately a little bit of an older state. I hope you can read it. And if I could find my mouse. Let's see if the video will play, because I thought a live demo would be stupid. So in this case, this is you start out with pulling an image. Then you have to do nasty manual steps, and that is switching to it, then copying over important files like the fstep, because fstep is not usually the one that's in the container image is not the one that you want. Then usually you also want something like resolve.conf to have network resolution, and all this part is not really necessary to do manually because I wrote a script that does this for you. I just didn't re-record it because I wrote it, I think, on a train, and yeah, that wasn't the best place to record things. Then you need to reinstall the bootloader, because otherwise the whole thing doesn't boot, run Dracut, regenerate the grub config, and reinstall the bootloader, and then reboot, cross your fingers. Then you get greeted with an ugly, ugly bootloader that indicates that something changed. And if you did everything right, it worked. And yeah, that's kind of it. And what's left to do? Actually a lot, and the most important part is actually testing this more in production and give it far more testing. Also do something about the etc handling. So copying over config files from the previous snapshot to the new one is really ugly. I've started to work on something that has the creative name Vindicate, because it bind mounts your configs somewhere outside. The UX is pretty horrible, and kernel updates will most certainly break the whole shebang. There is also the need for image builder support, but fortunately Kiwi already merged it, so you could in theory use it already with Kiwi, but unfortunately you need a patch transactional update because that one isn't upstreamed yet. So with that, there's one action item for you. Look at the source code. If you have to vomit, I'm sorry about that. I'm not the best Go programmer. And with that, I'd like to thank you for your attention, and if you have any questions, I'm open for them.
A question about the name. Is it related to like Snap from Canonical, or is it just unfortunate?
So, little bit of history. I'm very uncreative when it comes to names, and so I asked some LLM, and an LLM came up with that. So I blame the LLM. It's not related to Snap whatsoever.
In prior work, have you checked how Illumos uses OCI images inside Linux zones? Because this rings a bell.
No, I didn't know that they do anything, so no. I think that was the 5 Mississippis, so thank you for your attention.